The next big topic we're going to talk about is prime factorization. Prime factorization is absolutely something that you guys need to know how to do. And luckily, it's something that's pretty easy. I don't really find that students have a whole lot of trouble with this, so that's a good thing. So prime factorization is when you represent a number as the product means multiplication, of prime factors. So for example, if you write the number 10 as 2 times 5, you wrote it as a product, see the multiplication, of prime numbers. 2 and 5 are both prime. And then there's this thing called the fundamental theorem of arithmetic, which must be pretty important if they call it like the fundamental theorem of arithmetic. And that is that every single composite number can be written as a unique product of prime factors. So there's one and only one way to do it, and you're going to have a product of prime factors. So how do we come up with the prime factorization? Well, there's a couple ways you can do it. One way is using what we call factor trees, and the other way is called division by primes. So I'm going to show you both ways, and they lead to the same results. So you just kind of decide which way you like to do it better. So with factor trees, you start off with just whatever number you're trying to find the prime factorization of. Start with that number and just find two numbers that multiply to be the number. This is where the divisibility rules are really going to come into play. So when I look at this number, I'm like, well, I know it's even. I know that 2 will divide into it. I know that 4 will divide into it. If I add up the digits, I could figure out if 3 would divide into it. So 4 plus 1, that's 9, so I know 3 will divide into it. So sometimes if you need a starting point, those divisibility rules are helpful. I'm just going to start with 2. I think that's the most obvious, that this is an even number. So we're going to branch off, and I'm going to say it's 2 times 72. And when I get to a prime number, I'm going to circle it. So that little branch of the tree is done when you get to a prime number. Now let's break down 72. 72, that's also even. We could call that 2 times 36. There's another prime. 36, there's a lot of ways you can do this. You could do 6 times 6. You could do 2 times 18. You could maybe decide to do 3 and 12. Maybe I'll do that, because 36 is divisible by 3. And then I can break down 12. 12 is 3 times 4. And 4 is 2 times 2. And every time I get to a prime number, I circle it. And then once I'm done, you'll have all of these little leaves at the end that are circled. Now you've got your prime factorization. All you have to do is actually write it out. When you write the prime factorization, you always want to go from low to high, like put them in order from low to high. Don't just put a random order. And then I'll show you how you can also use exponents. So we have a bunch of 2s and 3s. I have 1, 2, 3. I have 4 2s. So we can write it like this. There's my 4 2s. You can use an X or just a dot if you want to use a dot. And then I have 2 3s. So that's one way to write it. See how I went from low to high? So 2 times 2 times 2 times 2 times 3 times 3. And if you use a calculator, if you multiply all of this up, you should get 144. The other way you could write this is you could say 2 to the 4th power times 3 to the 2nd power. So that's a little bit shorter way to write it if you want to use exponents. For a lot of the applications we're going to see in this class, it's like you can string it out like this, the long way, and that's actually, we're going to use more than we are going to use the exponents. So either way, but that's how you would find the prime factorization of 144. So your answer would be either this guy or this one. That's the prime factorization. The factor tree is just the tool that we use to get to the answer, but this would be your final answer up here. So now let's try 1260. When I look at this number, 1260, the first thing I see is it ends in a 0, so I know it's divisible by 10, so I'm actually going to start there. I'm going to say 10 times 126. That's a nice, easy way to break that apart. And 10 is 2 times 5. And those are both prime, so that little branch of the tree is done. Now for 126 is even, so maybe I'll do 2 times 63. And then 63 is 9 times 7. And 9 is 3 times 3. So do you see that as I'm doing this, when I get to a prime number, I stop and circle it. So then the way we could write out 1260 as a product of all these primes, again, please do them from low to high. So there's two 2's, and then I have two 3's, and then I have a 5 and a 7. So that would work. 2, 2, 3, 3, 5, 7. Just put multiplication symbols between them. It's not a list, it's actually multiplication. Or you could shorthand it with exponents and say 2 squared times 3 squared times 5 times 7. Either way, those are both perfectly acceptable answers. And that's how you find the prime factorization using a factor tree. So another way to do this is using what we call division by primes. And it's essentially the same thing as a factor tree. It just looks a bit different on paper. Okay. So let me show you how these are going to work. So using division by primes. All right, so we're going to start, it's not really like long division, but we're actually going to start at the bottom and we're going to stack it up. It's kind of like that scaffold algorithm a little bit. But the idea is that you only want to divide by prime numbers. Okay, don't divide by anything that's composite. So I'm going to start kind of down here at the bottom. And I'm just going to start dividing by prime numbers that divide evenly. So I see that 588 is even, so I'll divide by 2. And if you divide it by 2, you will get 294. And then we're going to divide again. I know that's even. I'll divide by 2 again. If you divide by 2, you get 147. Well, that's not even, so I know I can't divide by 2. I wonder if I could divide by 3. Let's see. Let's add up the digits. 7, 8, 9, 10, 11, 12. So that sum is 12, so I know 3 will divide into it. If you divide 3 in there, you're going to get 49. And I happen to know that 49 is divisible by 7. You get 7. And 7 is divisible by 7. You basically go until you get 1 up here at the top. So you stop once you get to 1. And your prime factorization is going to be all of these numbers that are along the left-hand side. So you would say 588 is 2, I'm going to use dots, times 2 times 3 times 7 times 7. Or you could say 2 squared times 3, I guess that would be to the first, times 7 squared if you wanted to write it with exponents. But either one of those would be fine, either way you want to write it. So you see we're just like dividing up. And then all the numbers along the side would be all your prime factors. So let's try 324. Or maybe you want to pause the video and try it yourself. So it's even. I know I can divide by 2. When I divide by 2, I get 162. I'll divide by 2 again because it's even. When I divide this by 2, I get 81. Now 81 is no longer, that's not divisible by 2 anymore, but 81 is divisible by 3. So if I divide by 3, I get 27. And I can divide 27 by another 3. I'll get 9. And I can divide that by 3. That gives me 3. And I'll go one more time until I get a 1 at the top. Remember, you want to stop once you get to a 1 at the top. And all of those numbers are going to be your prime factorization for 324. We have two 2's. Again, I'm going to use dots. And then we have a bunch of 3's. There's 4 of them. So you could also write that 2 squared times 3 to the 4th if you wanted to write it that way. So that's how you do the prime factorization. Remember, this is the end game here. We're getting this answer, this list of prime numbers that multiply together to be the original number. And you can always check your answer by multiplying your prime numbers together and see if you get the number you started with. And you can do it with a tree, or you can do it by dividing by primes.